Eric Darling here with Darling Data, and in today's video, we are going to talk about uh, how to fix parallel skew, or rather, how I fix parallel skew for a particular query. All right. I can't pretend this is going to be the thing that you do every single time you have this problem, because this is hopefully a rare problem, at least in today's day and age, but you can still run into it plenty of times. Lord knows I do. And I find it interesting enough to talk to you about. So if you find this interesting, well, stay tuned. Down in the video description, all sorts of helpful links. Perhaps you have lots of parallel skew and you would like a young, handsome consultant with reasonable rates to come fix it for you. You can find all sorts of helpful links to do that. You can also buy my trainings. You can also support this channel with money, not just with like various forms of internet applause. You can ask me office hours questions. That is a totally free endeavor for you. And I will answer 5 of those every Monday. And of course, if you enjoy this content, please do like, subscribe, tell a friend or two, tell your AI girlfriend who hopefully wasn't too terribly affected by the recent AWS outage. We pray for her well-being. I will be at Past Data Community Summit in Seattle, November 17th to the 21st, giving 2 days of the best T-SQL pre-connery that has ever existed with Ms. Kendra Little. And then, I don't know, well, hopefully I can talk about my other upcoming stuff soon. It's just, people are very slow to announce things. Apparently they just like to wait for excitement to boil over. But anyway, let's talk about this parallel skew stuff. I'm going to make sure I go to the right copy of Management Studio here. So well, let's start off on this tab. Because this tab is going to show us why we have such skewy problems with these. So what I've done with the votes table is something kind of mean. And so to give a little background on this, when you have very skewed data, that can lead to very skewed parallelism. And in the public version of the, Stack Overflow database, swallowed a bug. Most of the voting history has been anonymized, of course, because voting is a private endeavor, it should not be made public. And so what I've done is I've made a copy of the votes table, and I've set the user ID column equal to whatever the vote type ID was. So vote type ID is the number from like 1 to 8 or something that has various types of voting that people can do on questions, comments, and answers and whatnot. Well, I guess not comments in this table. But so what I've done is I've effectively made a very skewed user ID column. And I've created an index and all this other good stuff. But this is the way that the user ID column breaks out. So for vote type IDs between 1 and 4, these are the most common vote types. Well, actually, 3 of them are very common. One of them is not terribly common. But vote type of 2 is an upvote. Vote type of 1 is accepting an answer as the answer, the little green checkbox. And a vote type of 3 is a downvote. So, sorry, upvotes, accepted answer, downvote, if I have my voting history correct here. And 4 is like offensive or something. So not too many offensive flags, sort of, because Stack Overflow is a place for friends. It's also going the way of MySpace, a place for friends at this point. But at some point I'm going to be giving demos on Stack Overflow, and someone's going to be like, "What is Stack Overflow? I've never heard of it." It's going to be funny. Anyway. Yeah, so this is the way that these integers spread out, and these are the numbers for those because we have a group by an account and whatnot. So 37 million, 3.7 million, 3.5 million, and 733. All right, so when we run a query that does like this, that does this outer apply and whatnot, and we look at the query plan, you may remember this from the original video that I did, and we come over and we look, I mean, not there, the tooltip is utterly useless for discerning what our problems are here. If we look at the way that rows were distributed across our DOP8 plus 1 threads, you'll see that they all ended up on thread 3, right? That number there will be the total count of the 37 million plus the 2 around 3.5 millions plus the 733. They all end up, so the parallel page supplier runs this hashing function And depending on how things hash out, that's how the rows get distributed to threads. It's dealing out all these rows. And unfortunately, our hashing function kept hashing these things out this way. Now, sometimes when you do this, you can set DOP to different numbers, like especially odd numbers, in order to get the different thread distributions. But I tried that for every DOP between 2, which got me a serial plan all over again. So theoretically, I mean, in reality, it was really between like 3 and 16 in order to get a different spread here. But they all ended up, I mean, not always on thread 3, but always all on a single thread. And you can sort of visualize how this happens a little bit differently if you rewrite the query to turn this from one seek into, I guess, 4 different seeks. So if you do one select for vote type ID 1, one select for vote type ID 2, and one for 3, and one for 4, and so on, and then you get the dense rank over those, then you get a slightly, well, you get a very different execution plan, but it helps you to sort of visualize things a little bit, right? So if you look at these, we get 1, 2, right? You can tell that's 37 million, or sorry, I think that's 3.7 million. That's 37 million. Probably. That's 33.5 million, and there's our 733, right? So we can see all 4 of the individual seeks when we do this. And if we go look, again, not at the tooltip, which keeps really making its presence felt here, we'll see all of the rows end up on thread 1 here, right? Which is, you know, not great still. And if we look down here, we'll see all 37 million rows. Well, they all ended up on thread 1. And then down here, there's 3.5 million rows all on thread 1. And over here, there's 733 rows all on thread 1. So all of these ended up hashing out to the same thread, right? Just in different seeks. And then if we come over about here and look, we'll see thread 1 gets all 44 million some odd threads, rows on one thread. So things do not end up better when we do this. SQL Server does not like, unfortunately, SQL Server does not like spread those out better or do anything else smarter. It all just sort of ends up a complete washout. Now, the one way that I was able to rewrite this query in order to get better thread distribution was to do this. So rather than correlate on the 4 vote type IDs that I cared about. Remember, because in the original query, what I had done was written where vote type ID is between 1 and 4 here, right? So we kind of narrowed it down. We kind of forced ourselves to have a crappy parallel distribution on this one, but it's a lot easier to do that intentionally than it is to get it to happen by accident. So we kind of forced the issue on that one. But what I was able to do to get this one worked out was to sort of nest things a little bit and put the numbers 1 through 4 into a values clause, right? And call that vote type, alias that column that comes from these as vote type ID. And then left join the select here and join that on vote type ID there and say where user ID equals user ID out here. Right, so it's still logically a correct query. And when we look at the query plan for this one, this is kind of at the intersection of fixing parallel skew and being batch mode friendly. Because what you'll notice in this plan, which is going to be different, so like just to come back to these a little bit, you see we have a parallel nested loops here, and for this one we have a parallel nested loops here as well, if I'm remembering correctly. I was. Wonderful. Yeah, so parallel nested loops. Good. Everything correct there. Now we get something different. We get hash joins. Right, we have 2 hash joins instead, and if we look, we have this constant scan. So this constant scan is going to be the 4 rows, the 4 numbers 1 through 4 that I put into that values clause. And if we look, I mean, there's obvious signs that we got batch mode, like the window aggregate here. The important thing is this query finishes in about 4 seconds. And the other queries over here, this one finished in 29 seconds, and this one finished in 59 seconds. So I guess writing the 4 seeks out as multi-seeks was at least somewhat helpful by about 20 seconds, but probably not where we want things to be anyway. But this query, if we come over and we look at the index scan over here, again, not the tooltip, we'll see that the rows ended up hashing out very nicely on this one, right? I mean, there's a little outlier here. Like, there's maybe not perfect, but way better than all 44 million rows ending up on a single thread. So this is sort of at the intersection of fixing parallel skew and writing batch mode friendly queries, right? Somewhere in there. But obviously this is happening in batch mode. If we look up there, this sort will be happening in batch mode. And since this sort is a child aggregate of this batch mode window aggregate, this sort operator is a child operator of the batch mode window aggregate. There we go. Batch mode sort, blah, 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 blah. Then the window aggregate can read from the batch mode sort using parallel threads. Usually the producing side of a batch mode sort will be single threaded, but not when there's a window aggregate involved. And so we get batch mode pretty much across this whole thing. And this is exactly what we want. It's just batch, batch, batch all the way down. And we get a much faster query, with much better thread distribution. So when you're dealing with parallel skew, particularly like the kind that you cannot resolve naturally, maybe by forcing a different DOP. Again, particularly odd numbered DOPs tend to fix stuff like this, but it didn't happen for me here. So I was forced to rewrite the query in sort of a weird way. But I've used the values trick in other contexts before. In order to get different query transformations from things. Usually you would take values and cross apply to them, but doing cross apply here, or it would be outer apply because it's a left join. Using outer apply here produced the same skewed parallel nested loops plan as before, which didn't buy me anything. But doing the join, that means you can't correlate inside of this. You have to do it outside of this. So you actually force SQL Server to do all this stuff and then join onto it here, and then correlate to the user ID that gets produced here after that. So it was a much more efficient use of threads and times, and of course getting batch mode involved was a very big help in making this thing go much, much faster, because we are processing a lot of rows, right? 44 million rows. You want batch mode for that many rows. That's a good number of rows to batch up and not deal with on a row by row basis, because internally that's what row mode is, one row at a time, and batch mode is of course multiple rows, SIMD instructions, CPUs and all that. So this was just a fun way to rewrite this query to fix the parallel skew, and as a happy side effect, a very happy side effect. There are no fiascos, just happy screw ups. I'm going to skip the alliteration on that one. But this is just a happy accident that batch mode also got involved when I changed the format of the query. Anyway, thank you for watching. I hope you enjoyed yourselves. I hope you learned something. And I will see you over in tomorrow's video, where we will abandon all parallel skewness. All right. Thank you for watching.